We want to simplify this. Looks very complicated radical expression. So if we look at it, we see square root 3, square root of 5, square root of 7 in the denominator. Those are simplified. Then the numerator will have square root of 15. Well, we want this square root of 15 to be written as the square root of 5 times square root of 3, right? In that case, just keep everything in the simplest form because the denominator will have square root of 3 and square root of 5. So similarly for square root of 35, we probably want to write as the square root of 5 times square root of 7. Oops, no, I want square root of 7. Doesn't allow me to write square root of 7. Let me write 7 first, and I delete this 5. Yes. So similarly, I want to write square root of 21 as the square root of 3 times square root of 7. Right. What about 5? 5, I want to write it as square root of 5 times square root of 5, right? Now, I see the members all related with the square root of 3 and square root of 5 and square root of 7. Now let's see, we can have common factors, right? And we see square root of 7, square root of 5 here, square root of 7, square root of 5 here. Okay, maybe if I want to switch those two, if I want to put it over here, well, I don't want to do that. Let me just copy and paste. If I copy this one, paste it to be here. So I can factor out square root of 3 from the first two. You see the first two. Square root of 3 is common factor. Then inside the parentheses, I could have square root of 5 plus square root of 7. So for those two members, square root of 5 is common factor. And inside the parentheses, I also have square root of 7 plus square root of 5. Okay, let's do that. So for the first two terms, let's factor out square root of 3. Then inside the parentheses, I have those two. And for the second, let's factor out square root of 5. Okay, so this one, let's have the parentheses outside. Now you see I have common factors. Square root of 7 plus square root of 5 is a common factor. So then I can rewrite this as square root of 3 plus square root of 5. So this becomes a common factor now. So the numerator, I have two factors now, right? How nice. What about the denominator? The denominator, we check, we see, okay, we have 2 radical 5. Maybe I can write as 2 as 1 radical 5 plus another radical 5. In this case, I still have square root of 3 plus square root of 5 in the numerator, square root of 3 plus square root of 5 in the denominator. Let's put parentheses around so it looks more obvious. Then square root of 7 plus square root of 5 in the denominator and also in the numerator. But just in the denominator, we'll have this addition. In the numerator, it's a factor. So what if I switch it? Let's call this k, right? What if I do k minus the 1 over k? So let's try to do 1 over k, 1 over k. Because in the denominator, if I have a factored form, it would be much easier. 1 over k, the denominator would be product. The numerator would be addition, right? Because the numerator is addition, the denominator is a product of 2. That means I can split into 2 fractions. So I just copy and paste this one. I split into 2. So this one, so the 2 numerators, right? One is the square root of 5 plus 7. One is the square root of 3 plus square root of 5. Now, in the numerator and in the denominator, I have common factors. That means I can simplify them. Something divides itself equals to 1. Okay, and same thing for this one. Square root of 3 plus square root of 5 divides itself, becomes 1. Now I have this. Okay, I have this. So, but this is 1 over k. If I want to solve for k, I find a k, I need the denominator, I need to have 1 denominator. So what do? I multiply by its conjugate. I remember square root of 5 minus square root of 3 for the first one, divides itself. Minus square root of 3. I have to do the same for the numerator because I can only multiply by 1. And this 1 is something divides itself. In this case, it's a square root of 5 minus square root of 3 divides itself. So similarly for the second one, right, I'm going to multiply square root of 7. So let me copy this one, then I'll change the numbers. Copy, I only want to copy the numerator. So I don't really need this one. But for this one, I want to multiply square root of 7 minus square root of 5. Divides itself, right? So I have to multiply in the numerator and in the denominator. So I copy paste this, I change the numbers. So that's a square root of 7 minus the square root of 5. Right? This is the difference of 2 squares. The denominator I have a plus b times a minus b form. So that's a squared minus b squared. A is the square root of 5. So when I square it, I just got 5. Minus square root of 3 squared, it's just 3. So the denominator becomes 5 minus 3. Well, 5 minus 3, which is just 2. Similarly, for this denominator, I have a square root of 7 squared minus the square root of 5 squared, which is a 7 minus 5, which is also 2. Now I have common denominator of 2, right? That means I can add the numerators together. Add the numerators together. I just need to have 1 denominator now, right? But check the numerator. So I have square root of 5 positive, I have square root of 5 negative. So those two has to be 0. So I'm left with the square root of 7 minus square root of 3. Let's move square root of 7 to be front. Okay. So 1 over k is the square root of 7 minus square root of 3 divided by 2. Now I can write k. So k equals to just the inverse of this, right? Just the inverse of this. I'm still going to copy and paste. I only want to copy the numerators. Now 2 becomes now 2 becomes a numerator. I have to switch this one. So 2 is a numerator. 2. And denominator, I have square root of 7 minus 3. I have square root of 7 minus square root of 3. Right? But this, we have to simplify it. We have to rationalize the denominator. So again, I'm going to multiply by its conjugate. Its conjugate is the square root of 7 plus square root of 3. 7 plus is conjugated because it's minus, so its conjugate is plus. I'm going to multiply the same thing for the denominator. right? Because I can only multiply by 1. 1 is a transformer, 1 is something divides itself. Multiply by, I copy paste this, yeah. Okay. And this parentheses, I want to be outside. Symphony thing for this, I want this parentheses to be outside. So again, the denominator becomes square root 7 squared minus square root 3 squared, which is 7 minus 3, which is 4. Right, oops. So let me copy paste this, use this one. So the denominator, I get a 4. The numerator, I get a 2 times square root of 7 plus square root of 3. And 2 and 4 can be simplified. And it becomes half. The solution, the simplified version of the original just becomes square root 7 plus square root 3 divided by 2. Let me copy and paste going back. So this K, so this expression simplified to be square root 7 or half of square root 7 plus square root of 3.